Okay, guys. So today we're going to be talking about the answer to the question: how likely is it that we get three heads in a row when we toss a quarter three times? And to answer this, we're actually going to do two different methods. So the first is going to be looking at what are all the different things that can happen when we toss those three coins, and then we're going to look at a shortcut. So I want you to watch this first part because it's going to look at what we call the sample space. So the sample space is all the different things that can happen in a specific scenario. So what we're going to look at here is flipping three coins, and I'm going to lay out all the different scenarios that can happen when we flip those three coins. So first and foremost, we can obviously get heads, 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 and that would be our first scenario because we can flip the coin the first time we get heads, the second time we get heads again, and the third time we get heads the third time. So this is obviously the one that we want to happen. So I'm going to circle it, or the one that we're kind of interested in. So I'm going to circle that, and then I'm going to lay out the other things that can happen in the sample space. Okay, so I've drawn out all the different things that can happen when we flip those three coins. In addition to heads, 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 we can also get heads, 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 tails, heads, tails, heads, heads, tails, tails. And then if we flip a tails first, we can get tails, heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. So what you're seeing, and I'll tally these up, what we see is that our sample space has 8 different outcomes. So our heads, heads, heads is one of those outcomes. So our probability of heads, 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 which I'm going to write this way, is one successful way out of 8 total ways. So our probability here is 1/8. Now I will say this method only works because all of these outcomes are equally likely. Tails, tails, tails is just as likely, for example, as tails, heads, heads. So that's why this method works. But this is one way to tackle a probability problem where you draw out the sample space and then you look at the number of ways you can get a success, which in this case was HHH. And it is 1 out of those 8 ways. So in the next slide, I'm going to show you a much faster method that is a shortcut that looks at the probability of a heads on each flip. Okay, guys, so on this slide, I'm going to show you a shortcut for finding the probability of 3 heads in a row. And to do this, we're actually going to multiply probabilities to find what's called a compound probability, the probability that all these three things happen. So to do this, what we need to do is multiply P of heads, this P parentheses heads, and that's the probability of getting heads on any one flip. And we need to multiply P of heads times P of heads times P of heads, and that'll tell us the likelihood of getting heads, heads, and heads. Now, on the first flip, the probability of getting heads is 50%. You guys might know that, so we're going to call that 1/2. On the second flip, the probability is still 1/2. And on the third flip, the probability is still 1/2 because as long as this is a fair coin, it's equally likely to come up heads or tails. So if we multiply across those, we multiply across the top, we got 1 times 1 times 1, that's 1. If we multiply across the bottom, that's 2 times 2 times 2, that's 8. So what we see in the end is that probability of HHH is indeed 1/8. And that's just a way to sort of check our answer from the first slide, but also probably do these more quickly moving forward so you don't have to draw out the entire sample space for every problem. So hopefully this shows you how to do some basic probability math with coins. I think next time we're looking, I believe, at dice and die rolls. So that'll be a slightly different mechanic, but I think we'll have no problem with as well.